It's been said that the difference between men and boys is the price of their toys. But this is no toy. This is the Next Wave Shark HD544, and putting it together turned into a bit of a marathon. In this video, I'll walk you through building the base, assembling the big components, and the key assembly steps, plus a few mistakes I made so you can avoid them. If you're considering purchasing this or another large CNC machine, you need to build a base for it first. That way you can unbox the components and assemble the machine on the base as I'm doing here. Next Wave suggested purchasing a kit from Kreg Tools that yields a 64 by 64 inch work surface, then covering that with 2 layers of 3/4 inch plywood to make a 68 by 68 inch base for the HD544. I was able to put the base together myself, but if at all possible, I suggest you find a helper to make the task go more quickly and easily. You will definitely need someone to help you unbox the HD544 and lift the largest components into place. I went to Home Depot and bought 3 sheets of 4 by 8 foot hardwood plywood. You must use hardwood plywood for this because it's flat and free of the voids you would find in construction-grade panels. A Home Depot employee cross-cut all the 3 sheets to 68 inches, then ripped 2 20-inch wide strips from the 3rd sheet. I now had everything I needed for the top, so I rented their truck, another customer helped me load the plywood, and I drove off happily into the sunset. No, wait, that's not right. I drove the 10 miles or so to my store, unloaded the plywood by myself, then returned the truck. The person I hoped would be able to help me was busy working on his taxes, but he stopped by for a few minutes just to help me lift the first 48 by 68 sheet into place. This plywood is heavy and awkward to handle, and moving the larger sheets is definitely a 2-person job. The Kreg base already has holes drilled for attaching the plywood base. Easy, right? I could just drill up through the holes into the plywood. The problem is that the metal top of the base is a C-channel, and the drill bit isn't long enough to reach the plywood. Then I had an idea. Use a long drill bit. So I drove down the street to Ace Hardware, purchased a long 1/4 inch drill, but that didn't work either. I murdered a few naughty words and then formulated Plan C. Or was I up to Plan D already? I hoped I'd find a solution before I ran through the entire alphabet. Next, I tried the regular drill bit with an extender that I remembered I had on hand, but that wouldn't reach through to the underside of the plywood either. I was stumped, so I resorted to what I probably should have done in the first place if my brain had been engaged. I took into account the 2-inch overhang I wanted on all 4 sides, measured from the end and the side, marked the spot with a pencil, and drilled from the top down. Voila! I was spot on. Measure twice, cut once, or in this case, drill once. I'd purchased 1/4 20 bolts and the nuts to go with them to secure the first layer. I tightened the bolt enough to countersink the top flush with the plywood surface. In hindsight, 1.5 inch bolts would have given me more room to work with underneath the steel channel. With 1 bolt inserted, that corner was locked in place, so I moved to the opposite end next. I wanted to ensure I had a consistent 2-each reveal along the edge of the plywood before I started adding the rest of the nuts and bolts on that side. I drilled a hole and inserted a bolt into the second corner, and the reveal measured 2 inches along its length. I had already measured for the placement of the remaining bolts, so I drilled those holes next. I used a long drywall T-square to draw the center line and a small square to align the hole centers along that line. I was making progress now. With the small panel secured, I was ready to move on to the larger one. I butted it up against the short panel. I moved the long T-square into position to draw the line that would properly position the next set of bolts. I drew that line, then slid the panel back a bit so I could see where the holes were in the base. I used a small square to align the centers and mark the cross lines. In case you're wondering why I didn't just measure the distance between the holes and transfer those dimensions to the plywood, the holes are all at odd intervals, and using a tape measure proved inaccurate. This system was working much more smoothly and quickly, so I stayed with it. Whatever works, right? I secured the top plywood layer at 90 degrees to the first layer to add extra strength, and I used 1.25-inch drywall screws to hold the 2 layers together. I spaced the screws 8 inches apart along all 4 sides. Then I attached the second and third row 8 inches inside the first and second row. I didn't go any farther in than that because I'll later be adding T-tracks and an MDF spoil board system in that area. Once again, I needed help moving the large plywood piece into place and lifting the 2 Y-axes in the gantry. My brother-in-law Bill helped me with these, and he'll need to come back later when I'm ready to attach the gantry. There are 4 heavy steel brackets, one for each end of the axes. The instructions say to attach the Y1 ends with the included threaded inserts and bolts. For now, the Y2 axis will be free to move a bit, and the permanent attachment for this side will come later. The instructions say to place the Y1 axis 5 inches from the left end of the table, so I measured and placed it there, used the holes in the bracket to mark the locations of the needed holes, and drilled 5/16 holes for the threaded inserts. Then I moved the Y1 axis back into place. The instructions didn't specify how far from the front and back of the table to situate the ends, so I placed the rear bracket flush with the back end of the table. I realized I didn't have any Allen wrenches at the store, so I made one of many trips to Ace Hardware to pick up the 2 sizes I needed to complete this stage of the assembly. The assemblies, parts, and cables are all well marked. The loose cables have tags on each end to help you properly identify them when you plug them into the controller later. Bill stopped by again and helped me put the gantry in place. This is definitely a 2-person job. You need 1 person on each side of the gantry to lift it into place, and then you'll insert the 4 bolts on each side to hold it in place. The bolts hold the gantry's weight while you tighten the lock nuts. One word of caution, there's a small black wire on the Y1 side of the gantry that you must ensure is not run under the gantry. It needs to be loose. I've laid out the various cables and a few other parts here. The cables have labels on each end so you know where to attach them to the machine and to the controller box. Since the cables all look the same, you need a way to distinguish them after they go through the drag chain, and there are many cables that need to be connected to the controller box. For now, I set the spindle, its mounting bracket, and the desk boot on the table, but I'll move these to another table out of the way and bring them back when it's time to install them. Per the instruction manual, yes, I did read it, the Y2 rail has not been attached to the base yet. It's in approximate position, but once the cables and pendant are connected, the machine will move along the Y1 and nudge the Y2 into perfect parallel alignment. There are 2 drag chains, both the same length. One will mount on top of the gantry, the other to the left of the Y1 rails. Each drag chain has a bunch of little covers that need to be popped open so the cables can be routed through. One side of the cover has a hinge, the other a tab that snaps in and out of place. The side that snaps open has a slot for you to insert a straight screwdriver, give it a twist, and pop it open. It's kind of fun if you can get a rhythm going, and it makes it sound like popping bubble wrap. Once all sections are open, one drag chain is bolted to the gantry and the other to the table next to the Y1 rail. It'll be easy to place the cables inside, then close them up. The drag chains will prevent the cables from tangling as the gantry moves across the X, Y, and Z axes. I'll admit I can be dense sometimes, and perhaps this was one of those times. I had to climb onto a chair to reach the top of the Z-axis motor. The instructions showed where to mount the bracket to which one end of the drag chain attaches, and there was a little groove in the bracket, along with 2 mounting holes, so I was pretty sure where and how to mount it. But the idiot side of me was looking at the instruction manual, and there's a shark pictured on the end of the motor. The photo showed the shark facing the opposite direction from the shark on my machine. Additionally, I couldn't see the 2 mounting holes for the bracket. A little checking revealed the reason. First, the lighting in this room is poor, so that was making it more difficult to see details. Second, a plastic film covered the metal housing, including the holes. Once I located the mounting holes, I was able to punch the plastic and insert the bolts. Then it was an easy task to use an Allen wrench to tighten the 2 bolts, and the bracket was in place. I checked the instructions again before attaching the drag chain to the bracket I just attached. The 2 drag chain ends are different, which I discovered after looking at them more closely. I would have noticed this sooner, but apparently my brain was in low gear. I shakily climbed down off the chair to get the bolts I would need to attach the drag chain to the bracket on this end and to the top of the gantry rail on the other end. This is what the drag chain looks like when attached to the bracket near the Z-axis motor. The drag chain is secured with a 1/4 20 bolt and a lock nut. Now I need the bolt on the other end, and then I can run the cables through to the other drag chain running along the Y1 axis. Once again, I taxed my poor brain to figure out how to attach the second drag chain. This one has a long bolt plus a spacer to keep the drag chain away from the Y1 rail. The screw doesn't go through both sides of the drag chain. It's not long enough. It just goes from the inner side through the hole in the gantry. You'll need a small Phillips head screwdriver to secure this bolt. The instructions referred to the gantry side as a bent steel piece. So I was looking for a small bent piece of steel attached to the gantry until I saw the bolt hole and realized the instructions were referring to the gantry side. I ran all the cables to the drag chains that needed to go there, and the others went directly to the controller box. I was missing the Y1E and Y2E cables, so I called the factory and they'll ship them to me. The back of the control box is very well marked, and as I already mentioned, the cables are marked on both ends, so even an idiot like me should be able to make all the connections correctly. I'll put the pendant stand together later, but I'm anxious to see this machine do something, so I plugged the pendant into the controller box, plugged in the power, and the screen came to life. I think it's cool how the Shark fills the screen while the system boots up. The controls are then available, and you can use them to move the gantry from side to side and front to back, even diagonally. If you tap the jog setting, it moves the gantry in tiny increments, which is great for centering a bit and setting the X and Y axes to 0. You can see there's plenty of room for the Z travel up and down, and I'm sure this will come in handy when changing router bits, adding or removing the dust boot, and other tasks. The next step is to add the spindle. It was packed in a large box with other components inside a molded styrofoam box that fit the spindle perfectly. It's quite heavy and expensive, so it deserves special protection. There were protective caps on the couplings for the water hoses on top and another cap on the bottom holding a 1/4-inch collet in place. This model comes with 1/8 and 1/2-inch collets packed separately as well. Those 3 collets will give an unlimited number of bit choices. The spindle is attached to the Z-axis assembly with a mounting bracket, and the bracket attaches to the assembly with 4 long 1/4 20 bolts. I started them by hand, then I used an Allen wrench to tighten them the rest of the way. The mounting bracket is solid on the left side and has a slot on the right. This allows room to slide the spindle into the bracket, and once it's in place, you tighten the screws on the right side all the way, making the spindle secure in the bracket. I wasn't sure what height above the table to set the bottom of the spindle, so I temporarily propped it up with a small box to hold it in place while I tightened the 2 right-hand bolts. Now I was ready to attach the 2 water hoses that would provide cooling to the 3-horsepower spindle. The kit came with everything needed: a bucket, a water pump, and 2 hoses. When I looked at the length of the hoses and the distance they'd have to travel from the top of the spindle through both drag chains and then down to the water bucket underneath the machine's platform, I could see they were not long enough. Another trip to Ace Hardware was in my future. But I could see that I had enough hose to run from the top of the spindle through the drag chain on top of the gantry, then down into the drag chain along the Y-axis before I ran out of hose, so I decided to go ahead and make the hose connections to the spindle. I'd watched several videos of others putting together the HD544, so I knew I would have to heat the hose end to expand it enough to fit over the coupling. I brought a little butane torch from home for this fun little task. Who doesn't love to play with fire when they get a chance? I heated the end of the tubing, started to install it on the spindle, then realized I needed to have the fitting in place over the tubing first. So I placed the fitting over the hose, heated the end once again, and this time I was able to make the connection. The second hose went on with a little less fuss, since I now knew what I was doing. Actually, that's debatable, but I at least like to think I was making progress. There was one more step I performed before running the spindle controller cable and the water lines through the drag chains. In addition to the components I mentioned earlier, a flow meter was part of the water cooling kit. I snipped one of the hoses a few inches from the coupling to add the flow meter. This little device visually alerts you that water is flowing through the line. If it stops spinning, that's an alert that you have a problem and should stop the spindle before it overheats. I heated the tubing, added the flow meter, then heated the top section and connected it to the flow meter again. Now there was a path for water to flow through the spindle's jacket and back to the bucket. I purchased some extra tubing and brass fittings at Ace Hardware to add enough hose to the kit's included hose to reach the bucket in its chosen location under the lower shelf. I'll test the flow rate before I fire up the spindle. Yesterday afternoon I put together the pendant stand. I was a bit confused by the last step of sliding the screen onto the holder because the holder was at 90 degrees to the top and it was impossible to swivel by hand. Then I decided to slip the mounting place over the bracket first. It slid on easily, and now I had plenty of leverage to turn the mounting bracket to the correct position. I'm not sure why it didn't come in that position, but lately a lot of things don't seem to make sense at first. You have a good view of the pendant screen here. I can move it from side to side on the mounting stand, and I can adjust the height if needed. I'll need to work with it a bit to find the most comfortable position. I found that I made a mistake when I routed the controller cable through the end of the top drag chain. When I moved the gantry from right to left, it put too much strain on the top mounting bracket and it snapped. I called Next Wave and requested a new bracket, and I expect to have that in a couple of days. In the meantime, it looks like I'll have to unsnap at least some of the clips on the top drag chain so I can reroute the connector the way I brought it through the end of the drag chain. You've got to learn to think in 3D when working on projects like this, and I'm still learning to do that. I set a couple of the T-tracks on top of the table so you can see what I plan to do next. I used the CNC machine itself to route the channels for the T-tracks, then attach them to the table with threaded inserts. Then I'll add MDF strips between the T-tracks. The MDF will become my spoil board, and I can easily replace the strips as they become damaged. Next Wave sent me the two missing cables, and I installed them on the Y1 and Y2 axes. As you can see here, the sharks light up on the end of each axis. The blue color indicates they're in a ready state. They turn green when the gantry is moving along the axis, and they turn red when the gantry reaches the end of its travel. I just added the holder for the touch plate a few minutes ago. The touch plate is connected to the pendant, and when I want to set the Z to 0, I use it to do so. I'll show how it works in depth in the next video. And that's it for today. Next time I'll install the T-tracks and MDF spoil board system, and I'll show you the touch plate process so you can zero the Z-axis the right way. If you want to see the HD544 go from assembled to ready to cut, that next video is the one to watch. I'll link it as soon as it's live.